Hello everybody, welcome to another video lesson. We are continuing our journey on trigonometric functions. Today we're looking at angles and angle measures. After this video, we'll be able to draw and find angles in standard position, and we're going to learn how to convert between radians and degrees to radians. All right, so let's hop right into it with our concepts. First off, angle measures. All right, first thing we need to know and understand and write down and commit to memory and completely understand and know and commit to memory and all those things. We need to know that when we have a standard angle, okay, or an angle in standard position, we are starting off in the positive x-axis, okay? And if we have a positive angle, then that is going to be going counterclockwise from the positive x-axis, okay? So counterclockwise is a positive angle starting at the x-axis, and a negative angle is going to be going clockwise in, again, starting at the positive x-axis, but then we're going to be going clockwise. So let's take a look at a couple examples here. If I have, again, always starting on positive x-axis, all right? So if I have this angle of 135 degrees, I am going to start right here, starting right here in my positive x-axis, pretend that's a straight line, and I'm going to rotate 135 degrees counterclockwise, okay? Likewise, if I have a angle of negative 210 degrees, again, pretend this is a straight line. I am starting, oh, that's actually kind of straight. I'm starting in the positive x-axis, and now I'm going negative 210 degrees, so that's going to be clockwise, because that is a negative angle. Again, counterclockwise is positive, clockwise is negative for my angle measurements. All right, make sure we understand that, because that is kind of the basis of working with all of our trig functions and understanding, especially when we get into our applications, the direction of all of our angles. Okay, and then we also need to understand what the angle is with the nearest axis. Okay, oftentimes it's going to be the nearest horizontal axis. Okay, so I also need to understand if I go negative 210 degrees from the positive x-axis, what angle am I creating with the nearest x-axis or the nearest horizontal axis? Well, from horizontal axis to horizontal axis, I have 180 degrees, right? So this angle here would be 30 degrees. Okay, so from a context of, or from a real world context, we might need to know what this angle is created with the horizontal, negative or positive. So I will need to understand what this is. Okay, likewise over here, I've got 135 degrees, which means that the angle created with the nearest horizontal axis would be 45 degrees. Okay, so make sure we are understanding that what our standard angle is and what the angle is with the nearest horizontal axis are two very different things. So here our standard angle is 135 degrees. Here our standard angle is negative 210 degrees. Okay, starting at the positive x-axis every time with our standard angle measurements. All right, let's take a look now at degrees and radians. Okay, we need to understand what the definition of a radian is. A radian is the measure of an angle when our arc is the same length as the radius of the circle. So let's take a look at this. If I have our circle here, okay, 1 radian is going to be this angle measurement when this arc, okay, this is the arc of this angle measure, that is going to be equal to this radius right here. From the origin to my circle here, that would be our radius, right? So when that value is equal to this value here, which is my arc length, that is how we define 1 radian. Now this is important to understand because we have a lot of formulas that are really derived from this definition of a radian. So we have to understand what this is, and oftentimes we need to use radians when we use formulas moving forward. Okay, so if the circumference of a circle is 2 pi r, then we can derive that 1 complete revolution is going to be 2 pi radians, right? You guys have seen this equation before for the circumference, And really, we get 2 pi radians from that, understanding what the definition of a radian actually is. Now, we can convert between the two, between radians and degrees, and we often will want to, especially if you guys will develop preferences on whether you like to work with degrees or radians. So in order to do so, we have these two conversions here. So if I have degrees and I want to convert to radians, so degrees to radians, whatever my degree angle is, so say I have x degrees here, I would just multiply that by pi over, and this is really pi radians, over 180 degrees, okay? 180 degrees and pi are the same thing, so that's how we are going to convert between our angles here. So if I have radians and I'm converting to degrees, so say I have x radians, okay, I would multiply that by 180 degrees over pi radians, and see how my radians cancel out, and I'd be left with degrees. Here, my degrees cancel out, and I'm left with radians. Okay, so these are the ratios that we're going to use to convert from degrees to radians and radians to degrees. Now let's take a look at this concept of arc length. Again, we said 1 revolution around a circle, that is going to equal the circumference of the circle from an arc length perspective. So if I start here and I rotate all the way around, right, that circumference is 2 pi r, 2 pi times the radius, right? 1 revolution all the way around. Okay, so we know that that 1 revolution in terms of radians would be 2 pi radians, right? We said that on the last slide. Now it turns out that the relationship between that circumference, that arc length, and this angle of 2 pi radians is equal to any arc length with any of the matching degrees and radians. What does that mean? Okay, if I have this angle here, this angle theta in radians, all right, this arc length, S, we call this S, has the same ratio, S to radians, or S to theta, okay? This is the same ratio as we have 2 pi r over 2 pi, okay? Now, this is an important concept to understand because this is how we get our equation for arc length, okay? If I were to go ahead and solve this for S, I got 2 pi over 2 pi, so those cancel out, and now I have S is equal to r theta. Again, since we derived this from the definition of a radian, my theta has to be in radians. It has to be 100% every single time. I cannot use a degree angle for this formula, all right? So S equals r theta, where theta is in radians, is the formula for arc length, all right? So those are our concepts for this lesson. Let's go ahead and look at some examples. We have angles in standard position. Draw an angle with the given measure in standard position. So I have an angle of 210 degrees. I can draw my x and y axis. Now 210 degrees is going to be all the way from 0 to 180 and then beyond, right? And then I'm going to add another 30 degrees there. So I've got 210 degrees. That's going to land me in this quadrant 3. This is the third quadrant. 1, 2, 3. And again, understand what the angle is that I create here with my nearest horizontal axis. This is going to be a 30-degree angle here, right? However, it's just asking to give me the, draw the angle in standard position, so I would go ahead and do that. But keep in mind what my angle is to the nearest horizontal axis, because that's often going to be very important in real-world applications, okay? Now, I have 210 degrees. Again, that is 180 plus this 30 degrees, right? From 0 to, from my positive x-axis to my negative x-axis, that is going to be 180 degrees, right? So 180 plus 30, that is our 210 degrees. That's how we get this angle here of 30, and we can kind of work with a lot of things in context, understanding this whole relationship between our horizontal axes and our final angle. Okay, so you guys go ahead and graph negative 45 degrees. Pause the video, see if you can't graph that. Okay, hopefully this is the angle that you graphed here, again, starting in the x-axis, but since it's negative, we are going clockwise. Okay, negative goes clockwise, whereas positive would go counterclockwise. Okay, so our negative 45 would land us in this quadrant 4 down here in the bottom right at negative 45 degrees. Okay. Okay, let's take a look at something called coterminal angles. Now, coterminal angles are ways that we can kind of express the same angle in multiple different ways. All right, so it's asking to find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. So essentially, a coterminal angle, if I have this angle 15 degrees, now the positive x-axis is my initial, okay, let me draw it a little bit straighter. Okay, this would be my initial side here for any angle. This would be initial side. And what we call our terminal side would be this dotted red line here. This would be our terminal side. Okay. So coterminal means that we share the same terminal side with this angle here of 15 degrees. That's what coterminal means. So how do we find a coterminal angle? Well, if I go around 360 degrees, right? If I have 15 degrees plus 360 degrees, I land at this same terminal side, right? So if I just take 15 plus 360, and likewise, if I take 15 degrees and I subtract 360, so this time I'm going this way, that would be this way, and this way I would go clockwise, okay, when I'm subtracting the 360 degrees. Okay, that again would land me at this same terminal side, right? So we can find coterminal angles by either adding or subtracting 360 degrees. That is the easiest way to find a coterminal angle. So I have 360 plus 15, that's going to give me 375 degrees, and then 15 minus 360, that gives me negative 345 degrees, right? So that's the easiest way to find coterminal angles. I'm just adding or subtracted 360 degrees. Okay, so you guys go ahead, find two coterminal angles, one with a positive measure and one with a negative measure of negative 200 degrees. All right, hopefully you took negative 200, you added 360, and you got 160 degrees, and then you had negative 200, and you subtracted 360 degrees, and you got negative 560. Those are our coterminal angles. Moving on to conversions between degrees and radians. All right, so we're going to convert each angle to degrees or radians. So we're starting off with degrees for first example. And I know that for every 1 degree, I can just multiply that by pi radians over 180 degrees, right? And in this case, my degrees would cancel out, right? So I'm going to take my 120 degrees, multiply that by pi radians over 180 degrees. Again, my degrees will cancel out. And I've got approximately 2.094 radians. Now, if it asks for an approximation, this would be a great approximation. However, if it asks for an exact value, then you're going to want to simplify this ratio that we have here. So in this case, 120 over 180, that simplifies to 2 over 3, and my exact value in radians would be 2 pi over 3. Okay, so depending on what it asks you for, understand how to simplify that or type that into your calculator. All right, now let's take a look at converting this radians to degrees. So you guys pause the video and use the same ratio to see if you can convert from radians into degrees. All right, hopefully you use 180 degrees over pi radians and you simplified, and then you got negative 67.5 degrees. Okay, so this is the process I'm doing that. If you got something different, make sure you check that out. Otherwise, let's move on to our last example of finding arc length. Okay, we have a circle with a diameter of 9 centimeters. Find the arc length of the center angle, or central angle. Find the arc length if the central angle is 60 degrees. Okay, keep in mind we're working in degrees here. Now round to the nearest tenth. Okay, our formula, okay, S equals R theta. S is our arc length. That's what we are trying to find the arc length, R theta. However, we are given an angle in 60 degrees. But what did we say earlier? Our theta must be in radians. So the first thing we need to do is convert 60 degrees into radians. All right, so our angle theta is going to be 60 degrees times pi radians over 180 degrees. And our degrees will cancel out, and we can go ahead and simplify 60 over 180 to pi over 3 radians, okay? And we're given our diameter, however, we need our radius, right? R is radius. So our diameter equals 2 times our radius, which is equal to 9 in this case. So if we divide both sides by 2, I get a radius of 4.5 centimeters. So now we have what we need. We have R, and we have our angle in radians. Okay, so we can go ahead and just plug this now into our formula. Our arc length is equal to 4.5 centimeters times pi over 3, and we will get an arc length of approximately 4.7 centimeters. All right, so that is it for this video, you guys. Good luck with your practice.